Hi everybody, today we're going to walk through a chi-squared goodness of fit test using Desmos. Our scenario is that a credit card company lets customers choose from 4 credit card designs. If customers have no real preference, we'd expect a uniform distribution, meaning each design is chosen equally often. So let's say we had 200 people that need to choose a design. With an even distribution, we expect 200 over 4 equals 50 people to select each type of design. So our expected counts for the 4 designs would be 50, 50, 50, and 50. Let's compare that to actual results where we look at which design 200 customers selected. We have that 70 chose design A, 40 chose design B, 50 chose design C, and 40 chose design D. With 4 categories, we're going to have 4 minus 1 equals 3 degrees of freedom in our chi-square distribution. Before we go to Desmos, let's talk about our hypotheses. Our null hypothesis is the designs are chosen equally. We have a uniform distribution. The alternative hypothesis is the designs are not chosen equally. In Desmos, we need to enter 2 lists, our expected 50, 50, 50, 50, and our observed 70, 40, 50, and 40. So let's type those in. I'll do a capital O equals bracket 70, 40, 50, and 40. Then I'll do capital E equals, and a bracket for a list, 50, 50, 50, 50. Now I'm going to open my keyboard, select functions, then I'm going to scroll down, and what I'm looking for is inference. On inference, we can find chi-squared goodness of fit. Here we need to put in observed, comma, expected. Then we're going to use the drop-down arrows and select what we'd like to see. So we can see on our counts, our observed and our expected. Let's click on contributions. The chi-squared calculation shows us how different the outcome is from what we expected. Chi-squared is equal to the sum of the observed minus the expected squared over the expected, and we do this for each of the outcomes. For example, if we take the observed 70 and subtract the expected 50, and we square it, then divide by the expected 50, we can see we get 8. That shows our chi-squared distribution from the data point 70. Desmos did that for the 70, 40, 50, and 40. Then if we select totals, we can see our chi-squared total was 12. Now let's open the significance test. This shows us our 12 marked on the chi-squared graph. It gives us our p-value of 0.007, and again it states our degrees of freedom as 3. We can click on the 3 dots and say Export Significance Diagram. This simply opens up the graph so we can see it in finer detail. Given our p-value of 0.007 being less than alpha of 0.05, we reject the null hypothesis. This means the differences we observed are unlikely to be due to random chance alone. There is evidence that customers do have a preference when choosing between the card designs. So even though we started with the assumption of no preference, the data tells a different story, and that's exactly what the chi-squared test is designed to uncover.